Hey guys, welcome to Practical Home Projects. Today we are going to be installing an outlet in the middle of a run. So the first thing first is to be safe. So first you want to check to see if the power is off. This is a non-contact voltage detector. So I hold it up. I see that that wire has power, so I'm going to turn the breaker off real quick before we get started. So I just flip the breaker. I see it's not registering anything, so I know that the power is off. So this is going to be for our kitchen circuit. We actually have a series of outlets. So this is going to be the second one in the series. The first one, if you look right over there. So this is the first receptacle in the circuit. It is a GFCI protected, and it's a 20 amp circuit, 20 amp receptacle. So that's going to protect every other outlet down the line. So the next one is actually going to be this one, which is just a standard 15 amp receptacle, and that is okay to put in a 20 amp circuit, just because you know that you're not going to be using all of them at the same time. So we've got our wires pulled out of the box, so the next step is to strip the ends to prepare them for attachment. There is a gauge depth measurement tool in the back of the outlet. If you're going to do a plunge type of attachment, we are going to be wrapping the wires around those bolts, so I'm actually just going to kind of eyeball how long I think they need to be. We are going to attach these 4 sheathed wires to the 4 bolts on the outside, and then the ground goes on the green screw. Since this receptacle has 2 bolts for the hot wire, which are actually internally bonded, if you can see that little flange in there, and then similarly for the neutral side, it's got 2 bolts which are internally connected, we can actually use this receptacle to complete the circuit across, and that's exactly what we're going to do instead of pigtailing these together. However, for the ground wire, there's only 1 screw, and actually per code you want everything joined before it hits the receptacle. So what I'm going to do for the ground wire is I'm just going to add a 3rd wire to this connection, to this pigtail, and then join that to the receptacle, whereas these are going to attach directly to it. So let me go ahead and take care of that first. So here I've got a scrap of copper wire. It's maybe 5 inches long, so I'm just going to wrap it around just like the rest of these. Make sure to wrap it clockwise so that it's threaded the same way as your screw. So usually about 2 turns will do it. And then if I had some needle nose, I would kind of pinch it nice and tight there at the end. It's good to make sure that all of your wires are approximately the same length so that they all fit inside the cap. So I think yellow is kind of the universal cap size. It can fit 2 or 3 14 gauge or 12 gauge wires pretty comfortably. If you're going to go up to 4 wires, you're going to want to use a bigger cap, and then as you saw for individual wires, I tend to use that smaller cap. So I just keep screwing this on. You'll feel it once you catch, and then it'll pretty much bottom out. Alright, so now we don't need the tip of this anymore, but we will need that end. So these are the 5 pieces that are going to connect. So I'm going to go ahead and pre-bend them. So whenever you wrap these wires around the screw, you want to make sure that you're wrapping it in the same direction that you're going to turn the screw. So I'll turn the screws clockwise. So these black wires are going to go on the right side, and you can even read the back of it. You probably can't read that in the video, but it says hot black wire there, and then it says cold white wire there on the silver side. So I'm going to go ahead and loop these pointed up, loop these pointed down, and then similarly the ground I'm going to loop pointed down. So I'm going to use this little hole in the side of my pliers to help me make the loops. Just saves a few moments. But you could easily do this with the side of the needle nose pliers. And then honestly, I usually end up having to sort of tighten it out anyway, because these loops are too big. And I made that one a little bit too wide, so I'm going to pinch it down a little bit. So now everything's shut off, so the order doesn't really matter, but it's usually best practice to start with the ground, then move to the neutral, then move to the hots. So I like to go ahead and sort of tuck the wires where they're going to end up going before I even make the connection, just to get everything organized a little bit. I will connect that ground screw first. Now neutral screw. I like to pull it in there tight so it doesn't slide out the front. And now for the hot wires. I mangled this one a little bit. So you'll see right there at the bottom, actually there's a little bit of the sheathing touching the screw, so that's not good. So I'm actually going to unbend it and rebend it. So now you see we have only metal to metal contact. So now something that I noticed after I started screwing these in is that this neutral screw, I actually put the wire in the reverse of the way I like to have it. There's nothing by code that's incorrect with this, but you'll see how these neutral wires are going over the top and they're wrapping around this way, whereas I did the opposite with this ground screw. It looks pretty tight, so I'm actually just going to leave it. But just know that normally I would have wrapped it around the other way. So now all that's left is tucking these in. So you can see I've already kind of got some folds going on, and I'll try to maintain those folds to make it relatively easy to get this in there. And then I usually use the drill for this last part. So that is it, folks. That is an installed outlet. You'll see this is a tamper-resistant outlet, which pretty much all of them are nowadays. That makes it much more difficult for a child to poke something in there. So all that's needed is to put a cover plate over this, and we are good to go. And as a bonus piece, this little tool is called an outlet tester. A lot of home inspectors use them just to kind of walk around and test outlets to make sure they're done correctly. This is by no means the end-all be-all, but it's a nice little follow-up test. So you'll see it's got 3 lights. There's the middle one and the right one are currently on, and if you see the diagram on the top, that means that we are wired correctly. We did not mismatch the neutral and the hot. We did not forget to attach the ground or anything. So that's a nice little follow-up check. This is also an easy one to tell if your power is on or not. So those are the basics of installing an outlet. We'll go over some more complicated scenarios in the future, but thank you for watching today. If you have any comments or any suggestions for me, leave that in the comment section below. And please like and subscribe if you can. Thank you. Bye.